Neglecting air resistance, with what velocity would a ball need to be kicked straight up to stay above the ground for at least 3 seconds? It says express the answer in meters per second rounded to the nearest tenth. And I think it's saying that because we don't really have much guidance here for sig figs because there aren't many numbers given to us in numerical form. Although it does say 3 seconds. I guess I could have said 3 point whatever 00 seconds or something. But anyways, I've said it that way. So how do you set something like this up? And I'm going to start by kind of drawing a picture here that, I don't know, let's say I've kicked a ball straight up here. So here's like maybe some ground where I kicked it from, and it's going to go up. And I'm going to draw this with some maybe horizontal motion so that it's easier for me to look at. And then somewhere further over here, it drops back down. And okay, that's the process. And we're neglecting air resistance, so that means we know we can use kinematics because it's basically free fall acceleration, right? So maybe that's something I can start with here, is to say acceleration is going to be equal to minus g. Since I like to work with an explicit minus sign, that means that I think in terms of my coordinate system, I think up is like positive and down is like negative. Okay, that might make sense. There's going to have to be some initial velocity here. There's going to be some overall time that this process takes. I think since it was kicked from the ground, it might make sense that its initial position was equal to 0. So let me actually write this as an x naught is equal to 0. And it returns to the ground, so I'm going to say that its final position maybe is also 0. That would kind of make sense. So let's take a look at this with the first kinematic formula. I mean, that's where we're starting, and I usually do a number of examples starting with one before I progress to the next, so that's maybe a good guess. But already looking at what I've written there, you can see there's some correspondence between what I've written down and what is in the first kinematic formula. So there it is. And then, like I said, the replacements I think I'm looking at here, well, let's see. I've got x naught is equal to 0, x is equal to 0. So really, these are both going to go to 0, right? And physicists will sometimes do this thing where they draw an arrow through something and then write 0 to indicate that. And what else am I going to do? I've got a is equal to minus g. So sometimes I make a list, but maybe I'm good to go here. And I can just say, okay, so this means 0 is equal to 0 plus v naught t. And then I'll make this replacement here. I'm just going to state that as a minus 1/2 gt squared. Hopefully that's all pretty clear that came from substituting in minus g for a. And I guess I didn't need all these zeros here, but what am I going to do next? Well, the thing is, I'm being asked about velocity. I think the question I have is, what is v naught equal to, right? So maybe what I could do is I could add minus 1/2 gt squared to both sides, and then I'd have 1/2 gt squared is equal to v naught t. As long as t is not equal to 0, well, oh, that's something I forgot to address. T is given to me, right? T is equal to 3 seconds, so that's definitely not the question that means. But that means I can cancel out a factor of that t there, and then see that I have a formula for a solution, because v naught is equal to 1/2 gt is what just popped out of that. And with the knowledge that t is equal to 3 seconds and g is equal to 9.81 meters per second squared, I can plug those numbers in. Okay. And again, this is times 3 seconds here. And then I can go to my calculator, and you can look at all the units there. I've got meters per second squared times something in seconds, so that's going to be in meters per second. And I put in 1/2 times 9.81 times 3 in my calculator. I get like 14.715, but it says to express it in meters per second round to the nearest tenth, so I think I can round that off to 14.7, write my units for meters per second. That was a lot of work, so I'm going to box the answer because I'm proud of it, I guess. I don't know. That means I'm ready to check. So there it is, 14.7 meters per second.